It's actually kind of this. I mean, while we're talking about cross-pollination and this notion of dipping your toe in the water, kind of in different fields here and there. One thing that attracted me to this topic, the search for life beyond Earth, was just how inherently interdisciplinary it is. It's not just astronomy, it's not just biology, it's not just geology or physics. It's kind of all those things thrown together. If you're looking for not just single-celled organisms and bacteria, if you're looking for things that can think and create and talk, if you're looking for things that are intelligent, then it's not even just the physical sciences. It's also the social sciences. It's also psychology and sociology and economics and all these wonderful questions. So it kind of seemed to just be this nexus at which everything was coming together. And also seeing how, for the first time in quite a long time, maybe for the first time in history, we were actually getting so much rapid progress in some of these little kind of subsets of this greater question of, is there life beyond Earth? Is there intelligence beyond Earth? And we're finding lots of planets. We're finding more and more about those planets, whether or not they are habitable and things like that. So yeah, there's this huge just burst of activity that I could see going on in this one part of this one domain that was contributing to this larger question. The traditional study that we're talking about, the notion of using big radio telescopes to look for radio signals, I think it's still an entirely valid approach. But we have to deal with the realities of funding, the reality of not everything being equally popular and compelling to people who either pull the purse strings or even just support it through their own private interests. So right now it does seem like people have been looking for radio signals for a long time. We haven't found anything. That doesn't mean they're not out there, but there's not a lot of positive results. So something like looking for signs of life in an exoplanet's atmosphere, it doesn't matter whether or not the life that might be there wants to let you know it's there. Here on Earth, we have photosynthetic plants, for instance, that pump out a lot of oxygen as part of photosynthesis. It's a byproduct of photosynthesis. They build their bodies with carbon that they suck out of the atmosphere using sunlight by splitting water, and then they vent all this oxygen into the atmosphere. Oxygen is a very highly reactive gas. It doesn't want to just linger in the air most of the time, at least not on an Earth-like planet. It wants to fall out of the air onto rocks and metals. More generally, when I talk about things like oxygen and methane existing in an atmosphere, coexisting in an atmosphere of an Earth-like planet, and how that seems to constitute a signature of life. Again, it's not just the fact that here on Earth, oxygenic photosynthesis, green plants produce oxygen, and methanogens, anaerobic bacteria produce methane. It's also that you have a thermodynamic disequilibrium. When you're looking for life more generally, you are looking for these kind of disequilibria in a way, because life as we know it does need to metabolize. It does need to take in energy. And then as a consequence of that, as an inevitable consequence of metabolism, it's going to have byproducts that it releases somehow, whether that's oxygen or methane or something else. Man, biggest surprise. There's so many. I mean, I guess there's two that really come to mind for me, and one is really just the difference between what we can do and what we are doing. One thing that really motivated me to write the book, other than just the fact that I'm seeing this kind of confluence of disciplines all coming together around this one question, is that we're finding planets that are increasingly quite possibly Earth-like. So they're smaller. They aren't balls of gas just hugging their suns in really close orbits. They're in potentially habitable orbits. They're of about the right size and mass that they could be, rocky and have thin atmospheres and have water on their surfaces. They could be like Earth. We're finding these bodies, these planets, more and more and more. They're pouring out of the sky. There's no sense that they're going to stop, that it's going to slack off and diminish anytime soon. So for decades to come, if we keep looking, we're going to keep finding more and more of these things. And yet, the investments right now are not really being made in I guess, the technical capabilities that we need to actually determine whether or not all these places, all these potential abodes for life are actually habitable. This disconnect really struck me, and the more that I got into it, the more I researched it, and I talked to the astronomers kind of at the forefront of the field. Just the more profound it became, the more tragic it seemed. Where we're just on the brink of these amazing discoveries, and yet we're actually not doing what it takes to actually go out and make them. And the other thing that I would say is. The other thing that really surprised me is just kind of the reality of deep time. I'm kind of rendered speechless almost. When you talk to people who study the evolution of habitability on the Earth, they look at the long-term stability of planetary climates, or they look at how things that are today's coral reefs and ocean basins and things like that become tomorrow's shales and limestones and things like that. And you really get them to unpack just how old the Earth is and all that history and how much it's changed. It's really humbling, and you can't really kind of encapsulate it all. You can't hold it all within you. And it really kind of made me a little depressed at times, honestly, because you realize how everything we're doing is just such a fleeting kind of blink of an eye, not even a blink of an eye in the history of the planet. And yet, of course, we have kind of so much power as a global technological civilization. We are actually, our actions are actually rippling down through the geological future of the Earth. The things that we're doing now as a global society do seem to have very, very, very long-term repercussions for the future of the planet, and perhaps even the future of the entire solar system, depending upon whether or not we ever get off this ball of rock, right? But the trouble is, of course, getting there and getting in situ measurements that are good enough. And if you're just doing that with robots, it can be pretty tough. So in some ways, I think that, sure, life may be abundant in our solar system, and we just kind of haven't seen it yet because it's hard to find. I actually think it might be a little easier to build one of these life-finding space telescopes and survey the nearest 100 stars or 500 stars, say, than it is to, for instance, melt through the ice of Europa and send a probe all the way down there, right? Or build a huge drilling platform on Mars. Those are really significant. Those are going to require very, very large amounts of infrastructure very far away from Earth. I would say that if we find other instances of life in the solar system, and it doesn't appear to be an issue of contamination. It doesn't appear to have been transferred by an asteroid, for instance, from Earth at some point, one of these great impacts that chips pieces of Earth off and flings it out someplace, and bacteria hitch a ride. I think if that does happen, that's actually kind of bad news for us as a species, as a technological society. And the reason why, of course, is because if life is just everywhere out there, and yet we see no one to talk to, and we see no evidence of spacefaring cultures and technological societies. Yeah, all that stuff, all the water on the moon and things. It seems less an opportunity for in situ life and bacteria and stuff, and more an opportunity for us. It's like, hey, let's go out there and use that. That could be rocket fuel. That could be that could help cool reactors. That could help cool big solar power facilities on the lunar far side or lunar poles. There's all kinds of stuff out there. The solar system, I think, is our birthright.